So after my Turnigy quadcopter video, I've had a lot of requests from people asking basically how do you reflash the ESCs. The fact is it's basically identical to every other ESC flashing tutorial or whatever you've seen. Pretty much all of the ESCs, except a few, all use the ATmega8 microcontroller. So apart from a few, like I said, that use the some Silicon Labs chip or something like that, basically all the ESCs, all the pinouts are going to be the same. The only thing that really changes between them is what firmware you put on. So for the Multistar ESCs, no exception, they still use the ATmega8 chips. Only difference though is if this is the 20 amp ESC, this uses the standard TQFP ATmega, which is pretty easy to solder wires to. But if you've got the 10 amp Multistar ESCs, they actually use the smaller, I think it's an MLF package. Basically the pins are still accessible from the outside, but they're a lot smaller. You basically have to solder a single strand of wire to them. I mean, it's doable. I've done it myself, but it's pretty time consuming and complicated, so unless you really need 10 amp ESCs, I'd probably avoid those just until maybe Hobby can get around to actually putting some decent firmware on them. Like I said, being Multistar ESCs, Hobby can go on about, oh, these are high performance, fast response time. Look, they've even got, it's probably not going to focus, but there's a little line down here about them being 480 Hertz. I mean, they might update at 480 Hertz, but they've still got like all the, I don't know what they call it, the throttle curving stuff on there, so you don't strip your gears or whatever, but who has gears in multi-rotors anyway? So you are going to have to reflash these if you want decent performance. I mean, it'll fly without, but like I said in the other video, it's definitely a lot better to do it. You'll notice this one already has been opened. This is actually off the quadcopter, so I've already reflashed this one. But I don't have any others, so this is going to have to do. So you're going to need a few things, obviously the ESCs. You're going to have to do 4 of these, obviously, or however many you've got. So if you don't feel like soldering directly to the chips and you've got a few ESCs to do, you might consider buying the little pushover flashing tool. I didn't bother because, well, it's 20 bucks. I can solder wires to it, and I sort of wanted to do it there and then, so I'm going to do it with the just soldering wires to it. I'll show you which pins to hook up, where you can solder to. But if you get the flashing tool, obviously it's going to be a lot easier and faster. So ESC, you're going to need some sort of sharp knife, scalpel, hobby knife, whatever. Some heat shrink. Make sure this is big enough to fit over your ESC, because obviously you're not going to be able to reuse this heat shrink once you're done. So I forget what size this is, I think it's 20 mil or something like that. Blowtorch for the heat shrink. You're going to need a bit of wire. I like to use this ribbon cable because it's fairly small. You're going to need 5 conductors in total. Sorry, you're going to need 6 actually. So yeah, 6 conductors of fairly fine cable. An Arduino, and like I said, I used an Arduino just because I had one on hand and I didn't have, what do you call it? An AVI ISP basically. So an Arduino, you can program it as an ISP and that works just as well, but it just takes a bit more setting up. So if you've got an ISP, just follow the well, in the other ESC flashing tutorial. And if you're using the Arduino, you're going to need LED as well. Preferably 2 LEDs, or I'm just using one of these common cathode RGB LEDs. This is just to sort of give you an indication of what the program is up to, whether it's failed, that sort of thing. And obviously you're going to need a soldering iron and some solder, whatever. You don't need anything fancy. A lot of people say, oh, don't use cheap-ass soldering irons on SMD. Well, fact is, I've been using this for 13 years. I've done, soldered MLF packages with it, seriously, and it's a $13 iron, so it's basically whatever you're used to. So don't go out and buy anything fancy to do this. Whatever iron you're used to. Obviously, don't go using, a massive 80-watt automotive iron or something like that, or a gas iron, but you don't need a full $300 temperature control station to do it. I'd also recommend using standard leaded solder. This is just the standard 6040 leaded solder. Get it as fine as you possibly can. This is 0.7. 0.7 is alright, but realistically when you actually solder this, you don't put any solder on the pins at all. You only tin the wires and then you tack them on, so that's actually really important, otherwise you're going to mess it up. Obviously also you're going to need the firmware, which I'll actually include in the description. I did post a link to a website that actually had all this tutorial stuff written down, but for some reason it seems to have actually gone down, so hopefully this video should be enough information to get you going. Alright, so what we'll do is I'll just move the camera and then we'll start setting up. So now I've gone through and basically just prepared this ribbon cable. So what you're gonna do is just strip all the wires apart on one end. This side will be attached to the Arduino, so I've just gone through and tinned all the ends of the wires on that one, and this end here is what you're going to actually solder to the ESC. So give yourself plenty of length here to work with, because you're going to be putting these in at odd angles and all sorts of stuff. And on the end of these I've also tinned them. This is really important with SMD stuff. You always want to tin your wires first. But as you can see, just exposed a tiny bit of wire. Don't make them too long, otherwise you're just going to short things out, and it's basically all you have to do. So what you're going to do next, basically grab your Arduino, and you can use pin headers if you want, but I actually prefer to just solder them on the back. Less hassle and also less chance of it falling out and corrupting your ESC. So you're going to have to identify your SPI pins. So on the Duo Millenove Arduino, you're going to need pins, what are they, 10, 11, 12 and also 13, and you're also going to need power and ground. So I'll just get my, my soldering iron set up here and we'll start soldering the wires to the Arduino. Right, so now we're going to solder our wires to the Arduino. Like I said, you're going to need pins 10, 11, 12 and 13, and also 5 volts and ground. So what we'll do is we'll flip the board over, just make sure you know which pin's what, and then this is going to be a bit bodgy because the camera's in the way, but we'll see what we can do. Basically we go our 5 volt pin, the ground pin, bit of solder on those, and with this wire I prefer to use the rainbow stuff because you can actually color code it, so you don't have to look at your board every time. But obviously double check just in case, because if you do hook the power up incorrectly you will blow up your ESC. Solder it on there. So that's our 5 volts and ground. Flip this over. A ground, okay. This one here. Put all those on. Up in there. And like I said, you can use pin headers for this if you want, but I prefer to just solder them on the bottom. Just make sure you don't short anything out. Whoops. A little bit too early there. Right, that's all of our wires. So now what we're going to do is flash the Arduino with the Arduino ISP software, or the firmware I guess. So make sure none of your wires are shorting out. Then we'll just plug in the Arduino here. Like that. And then we'll start the Arduino IDE. And then all you have to do is, it comes pre-installed with every version of Arduino. Arduino ISP down the bottom of your example sketches here. And then you've got this. So this will actually tell you what pins on what version of Arduino correspond to the SPI pins. So like I said before, you've got the reset, and then the actual data pins and the clock pin, and then you've got the pins here if you're using the Arduino Mega as well. So this is where the LED comes in. What we'll do actually is we'll upload the sketch first, so just make sure we're on the right things here. Ooh. Okay, I have no idea which COM port this is. Alright, just going to have to double check which COM port this is. Alright, so it's COM23 on mine. So yeah, that's good to go, so I'll upload that. Alright, so that's all done. That's basically all we have to do in the Arduino ISP, but leave this open because it'll help you hook up the LED. So what I've got here is just a standard, like I said before, common cathode RGB LED. You can use separate LEDs and whatever you want. Because they put the ground pin in the middle, I can realistically only use 2 of the LEDs in it, so I actually just use, what did I use? 9 and 8, so heartbeat and error. So basically what we'll do is we just put 1 pin in ground up the top here and just bend the pins over, put 1 in 9 and 1 in 8. You should realistically use resistors, but I don't really bother, and it's a really bright LED, so that's basically all you do. That's ready to actually flash the ESCs now. So the next step is to actually solder the wires onto the ESCs, so we'll get set up and do that. So now we're ready to open up the ESC. The best way I recommend to do this is to basically cut down the side of the ESC. If you look on the side of it, you'll notice there's sort of a ridge here. That's the edge of the PCB, so if you cut along that really carefully, you're not going to damage any components if you cut on the top or bottom. So all I've done is just really carefully basically run a knife along the edge of that, and then all you have to do is just, with a bit of force, but just be careful and peel this the heat shrink off. The ESC should just come out. Now do be careful with these, with most of the ESCs, these heat sinks are actually held on by the heat shrink, so these heat sinks can actually fall off. They seem to be stuck on pretty well most of the time, but just be careful of that. Alright, so first thing you're going to notice, TQFP 80 mega. Compared to some of the other packages, this is relatively easy to solder wires onto. Now I'm not sure how well this is going to show up on camera, but if I get the light just right, basically you want to orient this so you can see in the top corner of the 80 mega here there's a little circle, and then the text is sort of across this way and the top of it being up here. So this is actually the pin 1 indicator, so if you leave that at the top, you can orient it pretty easily. So how this is going to work is the Arduino itself, 5 volt, is going to power the 80 mega. So you don't need to hook this up to a battery while you're doing this. Don't hook it up to a battery anyway, because you'll probably blow something up. So I'll link in a little, an image of the actual pinouts on this chip. But basically you're going to have to solder to, I think it's 4 pins on this, and then you can actually just pump power into these 2 wires up here. So the pins you're going to want to use is going to be this pin here, 4th one across the top from pin 1. This is your reset pin. This one on the corner here, right on the bottom corner, this is the clock pin, and then you've got the 2 data pins here. So as you can probably see, there's some solder already on them, so like I said, I've already flashed this one. But yeah, I'll see if I can get the camera on a better view, and I'll sort of try and give you an idea of how to actually solder wires onto these pins without shorting them out or whatever. Alright, so the first thing we'll do is actually solder to the ATmega chip itself, just because it's a bit easier. So like I said, orient it so the pin 1 is at the top here, and then what we'll do the reset pin first. So what this allows the Arduino to do is basically reset this chip, which lets it program it. So if you go back to your Arduino here, if you look at the Arduino ISP documentation, it says slave reset is pin 10. So pin 10 here, we've got the purple wire. So this purple wire will solder to the 4th pin across from the pin 1 on the top here. So this is actually pin 1 on the side here, and this is actually the last pin. So 4 pins across from the last pin, or basically 4 pins across from the top. So what you want to do, make sure your iron's clean, just on a bit of sponge. You shouldn't have to put any solder on your iron, because you've already put it on the wire. And then what you do is separate your wire here. This is probably going to be a bit hard to see. Let's see if I can get this into view properly here. I'm sort of shadowing myself. And basically what you need to do is just sit this wire on top of the pin. Keep all the others out of the way, obviously. So if you just sit the wire on top of the pin, heat it with your iron, just a tiny bit, because you don't want to overheat the chip or bridge any of the pins. Just have a look at this camera doesn't seem to automatically focus, but basically just double check your connection and make sure you're not shorting out any other pins. So yeah, that looks good. That's our reset pin. The next one we'll do is our clock pin, which is this one down in the bottom corner here on the side. So looking back at the Arduino ISP sketch, the clock pin is pin 13. So if you look on your Arduino, pin 13 in my case is the black wire. So once again, we'll just spin this around. And whoops. This is really awkward to do with the camera here. Bit excess solder on there. Alright, so that's that one there. It was a bit of a pain to attach. Don't think I had enough solder on that one. Alright, so that's our clock pin. The next one we'll do is the actual serial data pin. So we'll do MISO first. So that's actually the far side one here. So the one on the far side here. And then if we look at the Arduino ISP sketch again, that's pin 12. So pin 12 is the white wire. So this is why you sort of need to give yourself plenty of wire, because now you have to actually put this pin around on this side here, and you don't really want them pulling on each other. So we'll grab our iron here. We'll put this wire around the side. Like I said, excuse the bodginess here, sort of working around the camera. Another thing to keep an eye out for is actual little blobs of solder on any of the pins. Sometimes you'll actually notice it from factory. Like I just found this one here, which might have been from me, but if this gets stuck in any of the little pins on the ESC, it could end really badly. So that's our one of our data pins on there. And the next one is actually probably the trickiest because it's right next to that other pin. So our last wire is this grey one here. So we'll grab our iron again. Tack that on there. Just make sure it doesn't short out onto the pin next to it. And like I said, if you don't feel comfortable doing this, you can buy the flashing tool, which you basically just push over the top of the chip, hold it down and program. It's a lot easier to do, but I don't know, I just felt like doing it like this. Alright, so that looks good, nothing shorting out. Just watch out for the back of the wires as well, because sometimes there's little components behind the wire that the conductor can actually short out on behind it. Right, so that's all our data pins done. All we have to do now is actually connect power. So this is pretty simple and straightforward. These are actually the BEC output wires on the side here, so you can actually just solder your positive to the red one and your negative to the brown one. And that's it, that's the ESC ready to go. So now that we've got the ESC all wired up to the Arduino SP sketch flashed, and we've got the LED indicator on there, now it's time to actually program it. So we've got the Arduino hooked up here already. When you do though, just make sure that none of your leads are shorting out and all that sort of stuff, otherwise you're gonna have issues. So we've got that hooked up. So we'll go over to the computer now. We've got the SimonK firmwares all down here. For the Multistar ESCs, except for I think the 45 amp, but check the list, I'll link that in the description. It'll tell you which firmware to use for what ESC. So mine's the 20 amp Multistar, so we use the KDA.hex file. So what we're going to do, just to make this a bit easier, is we're going to copy this. We're going to put it in with AVR-dude. So if you go back to your Arduino directory, you can find this by going to Hardware, Tools, AVR, Bin, and then wherever your AVR-dude.exe is. So there it is right there. So we'll just stick this firmware file in here. That'll just make it a bit easier to reference. Next you're going to have to open up a command line, so we'll do that. Do a command prompt. And you're going to have to change this code up depending on like your user directories and whatever, but it should be pretty straightforward. So what you're going to do is basically just navigate to this directory here. So if you have this open, it just makes it a bit easier. So you can go, in my case, just CD my documents, and then what have I got? 0.3. Alright, so we're now in that directory there. This is the actual command we'll run. So what you'll have to change in this, depending on your setup, is your COM port of your Arduino. You'll also have to change your user directory here. So obviously if your name's not Daniel, that's not going to work. Your Arduino version, that shouldn't matter too much. But yeah, that's basically it. Oh, and also the firmware file on the end here. So that last part there, if you've got a different ESC. The rest of it you should all be able to just leave all the same. So we'll just copy all this, go to our command prompt here, I'll paste this in. Now one thing that I have noticed with this is sometimes it doesn't actually reset properly the first time. So if we hit enter on this, it might not do it. See what it does. Okay, so it worked that time. But what will sometimes happen is you'll get an error. It'll just end really quickly, and it'll say something like, you know, not in sync. Basically just run the command again straight away and it should work. So as you can see, that says it's flashed, it's checked everything, so that's actually flashed now. But I'll actually just demonstrate sort of an example. I think I should be able to get it to do it just by, if I unplug this, plug it back in again. It's something to do with the Arduino not actually resetting the board properly, so I'll try this again. Yeah, so you can see that error there, the get sync error. Basically, if you just press the up arrow key or just paste the command in again, do it again, and it'll work. So that's basically all you have to do. So that's the ESC Flash. Obviously, if you get an error while you're flashing it, then maybe you've hooked up your wires wrong, or chosen the wrong board rate or wrong COM port or something. AVRDude will give you an error anyway, and you should be able to track it down pretty easily. So basically, that's all you have to do. Now what we'll do is basically just desolder the wires from the ESC, and I'll show you how to finish it up. So now the final step of this, basically we've just got to detach all the wires and then put some heat shrink back on the ESC. So first thing, obviously, unplug your Arduino, and then all you have to do, this is a lot easier than soldering the wires on, basically just go around. My iron's dried out a bit. There we go. Whoops. So you can see I've pulled that wire off there, be careful of that. So you can literally just touch the wires and pull them straight off. Alright, and then what you want to really do is just thoroughly look over your board and make sure there's no jumpers between any of the pins. So this looks pretty good. Look out for little solder blobs, anything like that. Just a couple little solder blobs on there, just scrape them off and you're good to go. So now all you have to do, grab your heat shrink. You can put the old one back on if you want, you could just wrap some tape around it, but for the price of heat shrink, honestly, if you want, you could probably actually peel the label off and just stick it on the new heat shrink, but I've tried that and the labels sort of just tear, so whatever. Stick your heat shrink on. Should be a nice fit. Sort of put it about halfway so the wires get sort of equal coverage. And this you want to do quite quickly because you obviously don't want to overheat the ESC. So grab your blowtorch, put it on a lower setting. You don't want to just roast it. It's going to be a bit difficult to do here on the camera. Get this thing to the light. There we go. And then basically do one side at a time. It's just easier like that. So just quickly run it over. And like I said, you really don't want to hold it on there too long, otherwise you're going to cook something. Flip it over, other side, and you're done. Well, you probably fix up around the wires there a little bit, but not that big a deal. It's basically just to hold the heatsink on and to protect it a bit. So there you go, that's the ESC reflashed. Like I said, if you want to stick this old label back on there, you can probably cut it off and stick it on somehow, I don't know. Whatever you want to do, but that's ready to go. So now you've just got 3 more to do. You can whack them out pretty quickly once you've got all this set up. So your program is still ready to go. Just stick the new wires on the other ESCs and off you go. But like I said, if you don't want to have to do all that mucking around and whatever, just buy the little $20 flash tool. Take you 5 seconds to program each ESC. But yeah, hopefully that tutorial explanation was helpful. Like I said, the Turnigy quadcopter, once you've done this, it actually flies really well, but you definitely do want to do this if you want some decent performance. And this video will work for pretty much all of the Multistar ESCs. Just make sure you double check your firmware versions and that sort of thing, because obviously if you get that wrong, you're going to blow something up. Yeah, one thing I can't stress enough is always just double check your wiring, because like I said, if you hook something up, like the power up on these backwards, you're going to blow it up. If you put the wrong firmware on it, you're most likely going to blow it up, or it's just not going to work. And obviously always have it disconnected. Don't I mean, you can leave it on the motor if you don't want to have to undo all your wiring, but it's a lot easier if you can just move this around however you want. Anyway, that's it for this video. Hopefully it turned out alright. I'm sort of bodging it up using audio from the camera and doing a screen recording, and so I don't know how it's going to turn out, but hopefully it's good enough that you can see how it was done anyway. And like I said, if you get stuck, put a comment in the video, send me a message, or just Google it basically. It's nothing new, same as flashing basically any other ESC, so there's plenty of tutorials and stuff out there. Anyway, thanks for watching, hopefully that was helpful, and yeah.